The last couple of years has seen an increasing interest in artificial intelligence. This has been characterized by a rapid, globally transformative surge in capability and investment. It seems that the current AI boom has come about by the convergence of three key factors: big data, deep learning, and vastly increased computational power. AI is now integrated into numerous aspects of daily life and industry. How has Raspberry Pi positioned itself in this AI age? How has our mission to provide cost-effective, high-performance computing for businesses and the home played out in this recent AI boom? Well, join us as we discuss all things AI in this episode of our podcast. With me today is Naushir Patuck, who works as an engineer here at Raspberry Pi. We normally will call him Naush. Naush, can you tell us a little bit about yourself?
My name's Naush. I've been working at Raspberry Pi for probably just over 9 years, I think, right now. So I've done quite a few things at Raspberry Pi. Imaging, multimedia, in general kind of software development. More recently, I've been working on our AI products that we'll talk about in a few minutes. I have quite an interest in kind of AI and understanding what it does, how our users are going to use it. So yeah, looking forward to talking about that.
Excellent. Well, it's great to have you on the podcast. So we'll get started. So we'll just start off with a really basic question at the beginning. What is AI?
Right. So, firstly, AI has been around for as long as computers have, really. I'm sure there's plenty of definitions for AI. One definition I like to use is the ability for humans and users to interact with computers in a natural way. So that could mean talking to a computer and having it understand the meaning of what you're trying to convey, or computers or programs generating data and responses that can be received by a human in a natural way as well.
What are some recent developments of AI?
Yeah, so let's go back a bit. So I mentioned that AI has been around for quite a while, and people used to use AI to try and, I don't know if you heard about the Turing test, for example. They used to use computer programs to try and fool humans into seeing whether they were talking to a real human or a computer program. So they've been around for ages and ages and ages. In the past, generally, AI algorithms have been statistical in nature, meaning you use statistics to try and generate a response. More recently, we use deep learning algorithms, and over the last 10 or 15 years, they've become very, very popular. And the difference is they generate much better responses, much better output at the cost of a large amount of computation. And these days, we do have the computation resources to use these deep learning algorithms in real time. So they've become more and more popular. So in the current kind of phase of AI, we've got two broad categories of algorithms that we look at least at Raspberry Pi. One is kind of visual algorithms, and the other one is Gen AI.
Excellent. That's an interesting expression that you used. Do you want to explain what that means? What are the differences?
So visual. So when we talk about kind of this generation of AI technologies, we talk about like AI models. So we've got two broad classes of models. One is visual models. So visual models try and understand images and scenes within an image. So your object detection, object recognition, facial recognition, these kind of things that we've seen become quite popular over the last 5 or 10 years. Now, they used to run on classical statistical algorithms, but these days they all run on these new kind of AI machine learning algorithms. So those are the visual models we talk about. And then more recently, the Gen AI, so generative AI. Now, this includes your chatbots, your visual language models. So you provide a video and to the model, and the model understands what's happening in the video, and then you can ask it questions about what's happening. So has there been a person walking across this road, for example. You can ask it questions like that, and it'll answer you in a natural language way. So those Gen AI is the kind of latest buzzword, and Gen AI also includes these new kind of models that help users write essays or code programming snippets, things like that as well.
That's good. I mean, I think I'm familiar with that one.
Yeah.
Why would someone want artificial intelligence running on a Raspberry Pi device?
So let's talk about what happens right now with these big models. So you generate some data. You have to transmit that data to a cloud service, for example. The cloud service processes that data, runs it in a model, and generates a response and comes back. Now, there's several reasons why you may not want to do this. Number one is security and privacy. So you may have like a video feed of someone, of a house, an indoor setting or a private setting where you don't want those images or videos to go out to a cloud service that you have no control over. Yeah. So privacy is a big concern. You want to keep that running on a Raspberry Pi. Number two is costs.
Okay.
You may want to control your costs, and every time you send something to a cloud to use their processing power, it adds up. So these are the two big reasons. Number three is a bit more control. You have no control over your data if you send it to a cloud. A cloud service could use your data for anything else, maybe retraining their models or something like that. Maybe you don't want that. So all of these reasons are encompassed by what we call edge AI. And edge AI is where what we say is where we run the model, run all of the AI processing as close to the stimulus as possible. So now back to Raspberry Pi. So Raspberry Pi we can use Raspberry Pi as an edge AI device where it runs the model locally without sending any information to any cloud network, generates the response straight away, and you do what you want with that response.
That's really good. I think that explains it very nicely as well. Now, I recall that, earlier you had mentioned that, artificial intelligence has been around for quite a while. Now, keeping that thought in mind, how have people sort of enabled AI on Raspberry Pi devices in the past?
So, coming back to the kind of classical algorithms, people have been using the Raspberry Pi platform to run AI tasks for ages and ages, probably since the first Raspberry Pi. As an example, object detection or face detection on a camera feed. People use OpenCV libraries, if you're familiar with that, where they run classical algorithms right on the Raspberry Pi CPU, and they work. They work fairly well, but they're very slow. So you're talking about something like maybe the camera generates 30 frames a second, and your AI processing happens at probably about half or 1 frame a second. But people have used it. Another good example is something like speech to text and text to speech. Again, same problem. It runs, but it runs really slowly. Yeah. Good. So that's the past.
That's the past. I think now we can come to the present. And thinking about the present, really, I was going to ask, what are current AI products that are available on Raspberry Pi?
So we've obviously seen that people are asking more and more, have been asking more and more about what they can run on a Raspberry Pi. And over the last 2 or 3 years, we've released a family of AI products. So there's 3 main products actually that we've released. One is the AI camera.
Okay.
One is the AI Hat Plus, and then a successor to that, the AI Hat Plus 2. So let's talk in more detail about these. AI camera. So AI camera is a product that we partnered with Sony on. It's a standard camera module featuring an IMX500 imaging sensor. But the unique thing about this product is that on the sensor die itself, we have an AI accelerator. Now you can upload AI models on the to the sensor, and as the sensor generates the frames, it'll also run the AI model on your frame and deliver the results straight away, together with the image. So you can run AI workloads directly on the sensor device itself, which means this thing can run on a Raspberry Pi Zero class device, for example, or any Raspberry Pi with a camera attachment, and you can have AI-enabled workloads pretty much straight away. And we talked about the example where we do object detection using OpenCV at half a frame or 1 frame a second. With the AI camera, you will get 30, maybe even 60 frames a second of AI processing. So that's quite a big win. And all of that in a small form factor, like a normal standard camera module. That product is usable on any Raspberry Pi platform. But given the limited size and the limited memory capacity, there are limits to what models you can run on it. So the next product is the AI Hat Plus. Now this features a Halo neural network accelerator on an add-on board. We call the Hat board, which attaches on top of a Raspberry Pi 5. Now this talks to the Raspberry Pi over the PCI link. So it is a Raspberry Pi 5 specific product. But what you get is a huge jump in neural network capabilities. So it runs models faster, it can run bigger models, it can run models concurrently. So you can have multiple camera feeds feeding into this device and running AI workloads completely independently. It shares memory with the Raspberry Pi CPU. So the models can be quite big. And so as a little comparison, we talk about TOPS as a measure of performance. The AI camera runs at about 2 TOPS, and I should expand on TOPS. TOPS means tera operations per second. The AI camera runs at about 2 teraops per second versus the Halo that runs up to 26 teraops per second. So there's quite a big difference in performance there. One of the things that the AI Hat Plus allows you to do is use any camera module that you want with the device itself. So you're not tied to a single sensor. Now, one of the limitations of the AI Hat Plus is that it can only run visual models. And of course, all our users ask us, well, what can I use to run the Gen AI models? And that's not possible with the AI Hat Plus. So recently we introduced the AI Hat Plus 2, which does include Gen AI capabilities. One of the key differences is that the AI Hat Plus 2 has 8 gigabytes of onboard memory on the device itself, which means that you can run much, much larger models than you could with the AI Hat Plus. And internally, the chip itself has Gen AI acceleration capabilities. So you're now able to run chatbots, ChatGPT type clones directly on your device with no external network access needed.
Now, looking at the sort of current AI market, how would Raspberry Pi differentiate itself in the current market against competitor products?
Yeah, that's a good question. And being a software guy, my first response is the software integration. So we've worked really closely together with Sony and together with Halo on these products, and we've made a really, really tight integration with our camera stack. So we make it as simple for our users as possible to use our camera system. So that includes libcamera, PiCamera 2, or PiCam apps, and just directly interface with either the Halo device or the IMX500 device and get your AI capabilities. So we're talking about about 5 to 10 lines of Python code, and you'll have a full AI-based vision application up and running at the best performance you can get. Integration is really, really simple, and we spent a lot of time making sure that that works well. And it's also the interrupt we have. So you can run one of these AI tasks using our camera software on the CPU, on the IMX500, or on the Halo device, depending on what's available to you and what performance target you want, with minimal change to your application itself. Now, in terms of performance, the Halo device I would consider best in class. Given the price point that we are at, you will not get a better performing device, I don't think, given the power envelope we're working with as well. You can spend a lot more to get a better performing device, but you're talking about another tier of price and performance there. So all that included, I think these are great products. And speaking of the AI camera, I don't think I've actually seen or worked with a device that has onboard AI capabilities on a sensor itself. So I don't think there is another product out there that does the same thing as the AI camera.
Thinking now about sort of use cases now, what sorts of use cases or applications are you sort of seeing out there with the kind of current Raspberry Pi products, particularly the ones that you mentioned a few moments back?
Yeah, one of the interesting things about working with Raspberry Pi is we don't actually get to see what our broad user base uses our devices for. There are plenty of things that I have no idea where they're being used, how they're being used. But from a small survey, I do have an idea of some of the things that we use users use our AI products for. So we've seen a few use cases. For example, people counting in shops, security cameras where you can use facial recognition or object detection to detect things in the scene. In car parks where companies monitor the available space in industrial areas, in construction sites where people want to monitor whether the construction workers are wearing correct PPEs, things like that. Quite popular use cases. Some of the kind of crazier use cases are a lot in farmlands where people are counting the amount of sheep in their livestock, the amount of cows. Also in wildlife where people are trying to like, for example, there's been a recent project by an ecological conservation company where they are actually looking for specific endangered animals, and they're using object recognition and animal recognition really to see how many animals they can count going past a certain area. So that's quite interesting. For the Gen AI tasks, people are using it in areas where they'd rather not send their database to a cloud, so they map it locally and run their AI models locally. Obviously, these are kind of smaller data sets that people rather not share. So there is a limit to what you can do.
That's really good. Very, I'd say, very broad kind of use cases, really, from standard, I suppose, to even the more surprising ones, like the ones that you just mentioned. That's all well and good, beautiful things that you've said so far. Any challenges exist today with the use of Raspberry Pi AI products?
One of the challenges that users have faced is running their own custom models on these devices. And that's obviously a problem because a lot of these users aren't AI experts. So the steps taken to get a model that they already have running accelerated on one of our products can be quite challenging. And for that, we've worked very, very closely with quite a few key partners to improve the situation. So we have a strong partnership with Ultralytics, which is a company that makes probably the most popular vision models available today, the YOLO family. We can export their models directly onto our devices now through their interface, which is quite useful. So it helps the end user get their models running as quickly as possible on our device. We also obviously work closely with Sony and Halo to make sure that models that don't currently transform and run efficiently on the devices work properly. So we've done a lot of work around the ecosystem to help with this situation, and I think we're in a good place now.
And that's really good. It's good to see that it's, even though the challenges exist, but, what we're doing at the moment to kind of improve the situation.
This space keeps moving and moves really fast, so we keep kind of catching up and adapting to what's happening in the world today.
Excellent. That's really good. Now, when we think about people who are sort of building AI applications, is there any support that they can get from Raspberry Pi?
Yeah. So one of our most popular end user support channels is our forums. So we have dedicated forums for our AI products. Users who want to ask questions, have certain problems, or want to try and do a different type of integration than we've done, or even just show their new demos, for example, they can post on the forums. And the forums are monitored by me and by the engineering teams. So, you have direct kind of communication channel with the engineers who've worked on these products. So that's the first point of call. For the larger customers, and these are more geared towards the industrial customers, we have design partners who specialize in AI applications. So these design partners know our products, know our software, and will be able to help the larger customers with doing integrations or generating new products with our AI devices.
Brilliant. This has been really good. Thank you very much, Naush. This has been a very enlightening conversation.
Thank you, Ken. It's been a pleasure.
Thank you.